Hi, in this video we're going to be going through lesson 4.7, Real World Problems, Multiplying and Dividing with Fractions. We're going to go through 5 different examples in this video. In the first example, it says, a vendor at the farmer's market has 240 pieces of fruit. She sells half of it to one customer and 1/3 of it to another customer. How many pieces of fruit does the vendor sell? How many pieces of fruit does she have left? So I'm going to start by highlighting my key pieces of information, which is 240 pieces of fruit. Sells half of it to one customer, 1/3 of it to another customer. The questions that we're answering are how many pieces of fruit does the vendor sell, and how many pieces of fruit does she have left. We're going to start by drawing ourselves a bar model. And our bar model is going to represent our 240 pieces of fruit. And we want to split our bar model into pieces to help us figure out the answers to our questions. And so it might be helpful for us to figure out what the common denominator is between the two fractions in our problem. We have 1/2 and we have 1/3. Now the least common multiple of 2 and 3 is 6, so we're going to draw our model with 6 equal units in it. Since she sells half of it to one customer, we're going to shade half of our bar model in red, and half of our 6 pieces would be equal to 3 pieces, so we're going to shade 3 pieces, and we're going to label that 1/2. And then she sells 1/3 of her total to another customer. Now 1/3 of 6 would be equal to 2, so we're going to shade in 2 units to show what she sells to the other customer. We're going to label that 1/3. In our model, we created 6 equal units. Since we know that those 6 equal units total 240, we can figure out what one of those units is equal to by dividing 240 by 6. 240 divided by 6 is equal to 40. So that means that each of our pieces, each of our units, is equal to 40 pieces of fruit. Now our first question asks us how many pieces of fruit does the vendor sell? If we look at our model, we've shaded in 5 units. So since 1 unit is equal to 40 pieces of fruit, we can multiply 40 times 5 to tell us how many pieces of fruit are in 5 units. And 40 times 5 is equal to 200. And so the answer to part A would be 200 pieces of fruit. Part B asks us how many pieces of fruit does she have left? If we look at our model, we have 1 unit that we have not shaded. So we have 1 unit of the 6 left. We calculated before that 1 unit was equal to 40 pieces of fruit. So she has 40 pieces of fruit left. We can also solve the problem without using a model as well. We can calculate half of 240 by multiplying 1/2 times 240, which equals 240 halves, which we can simplify to 120. And then, since she sells 1/3 of the total to another customer, we can find 1/3 times 240, which equals 80, and then we add 120 plus 80, and that gives us 200 pieces of fruit that she's already sold. Then, since 240 pieces of fruit is our total, we can subtract 240 minus 200 to get us our answer to part B, 40 pieces of fruit left. Our next problem says Sophia has $480. She uses 1/3 of the money to buy a winter coat. She then spends 1/4 of the remainder on a pair of winter boots. How much money does she have left? We'll start by highlighting our key information. She has $480. She uses 1/3 of the money on a winter coat, 1/4 of the remainder on a pair of winter boots, and our question that we're answering is how much money does she have left? To start us off, I drew a bar model to show the 1/3 of the money that was used to buy the coat and what the remainder of her money was that she used to buy her winter boots. So, as you can see from our model, we have 3 pieces. One of those pieces is used for the coat, and we have 2 those pieces or units left. Since she spent 1/4 of the remainder on a pair of winter boots, we need to split our remainder part into 4 equal pieces. So each unit is going to be split into 2 pieces so that we have 1, 2, 3, 4 units. Then, since we want to split our total into equal pieces, I'm going to split the part with the coat into 2 pieces as well. So in total, we now have 1, 2, 3, 4, 5, 6 pieces in our whole. As a reminder, our whole bar model represents her $480. So based on our model, 6 units is equal to $480. Therefore, we can figure out how much each unit is equal to by dividing 480 by 6. $480 divided by 6 equals 80. So each of our units is equal to $80. We know that she spent 2 units on her coat because 2 units is equal to 1/3 of 6, and then she spent 1/4 of the remainder on a pair of winter boots, and so if one of the 4 units from our remainder was spent on the boots, we can shade that in to represent what was spent. Therefore, based on our model, 3 out of the 6 units was spent, and so she has 3 units left. If each unit was equal to $80, we can multiply 3 times 80 to get 240, which is our answer. So she has $240 left. Another way that we can solve it is by finding 1/3 of 480, which is the same thing as doing 1/3 times 480. And this will tell us how much she spent on her coat. When we find 1/3 of 480, that equals $160. We need to figure out what the remainder is to figure out how much she spent on the winter boots. So we're going to take our total 480 and subtract 160 which gives us 320. So our remainder is equal to $320. If she spent 1/4 of a remainder on a pair of winter boots, we can calculate what fraction of the remainder she has left by doing 1 whole minus 1/4. And so the fraction of her remainder that she has left is equal to 3/4. We can use that and multiply it by our remainder to figure out how much money she has left. So we're going to take 3/4 and multiply it by our remainder, which was 320, because remember we're trying to figure out 3/4 of 320. We can simplify to make our lives easier by dividing both 320 and 4 by 4. 4 divided by 4 is 1, and 320 divided by 4 is 80. And then when we multiply across, 3 times 80 equals 240, which is our answer. Our next example says Ben took a test with 3 sections A, B, and C. Ben spent 1/5 of his time on section A and 1/3 of the remaining time on section B. He spent 48 minutes on section C. How much time did Ben take to complete the whole test? So I went ahead and created a bar model to represent our total amount of time that he spent on his test, which we are trying to figure out. Now, since our fractions are 1/5 and 1/3, I found the common denominator between 1/5 and 1/3, which is 15, and so I split the bar model into 15 equal units. Our problem says that he spent 1/5 of his time on section A, and so 1/5 of 15 is 3. And so we're going to label that. Then it says that he spent 1/3 of the remaining time on section B. Since our whole total in our bar model is 15 units, and we use 3 of those units to represent 1/5, we have 12 units left, and 1/3 of those 12 units was spent on section B. 1/3 of 12 is equal to 4, so we're going to shade in 4 units to represent the time used in section B. The rest of the time was spent on section C, and we have an actual number for section C, which is equal to 48 minutes. If we count how many units we have left in our remainder for section C, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 units, and that equals 48 minutes. We can use that information to help us figure out how many minutes are equal to 1 unit of our model by doing 48 divided by 8. And 48 divided by 8 equals 6. So that means each unit in our model is equal to 6. We can use that information to help us figure out then how long it took for the entire test, because we know that 1 unit is equal to 6 minutes, and we have 15 units in our model. So we can multiply 15 times 6 to figure out how much time 15 units is equal to. When we multiply 15 times 6, we get an answer of 90. And so that means that it took Ben 90 minutes then to complete the whole test. If we look at another strategy that we can use to solve the problem, because Ben spent 1/5 of his time on section A, that means that the remainder of the time is equal to a fraction of 4/5. And so we can find what 1/3 of a remaining time, or 1/3 of 4/5. And this will tell us the fraction of the total time that Ben spent on section B. So we're going to find 1/3 times 4/5. When we multiply that together, we get 4/15. And remember, this is section B. And we know that section A is equal to 1/5 of the total time. By adding the fractions that we got for sections A and B, that will tell us the total amount of time that he spent on both sections A and B, which will then help us calculate the total time that he spent on section C. So we're going to add 1/5 plus 4/15. We need to find a common denominator, which will be 15. So we're going to multiply both 1 and 5 by 3. So that becomes 3/15 plus 4/15, which is equal to 7/15. To figure out what fraction of the time he spent on section C, we're going to take 1 to represent our total fraction of time, and then we're going to subtract 7/15. Remember, 1 is equal to 15/15. When we subtract 7/15, that equals 8/15. So 8/15 is the fraction of the total time that he spent on section C. We know that 8/15 is equal to 48 minutes. So we can figure out then that 1/15 would be equal to 6 minutes by dividing both numbers by 8. So 1/15 is equal to 6 minutes. Therefore, we can multiply 15 by 6 to figure out what 15/15 is equal to, and that is equal to 90 minutes. Our next problem says Alana makes 4/5 gallons of lemonade. She pours 1/4 of the lemonade into a pitcher and the remaining lemonade equally among 6 glasses. How much lemonade is in each glass? I'm going to highlight 4/5 gallons, 1/4, and 6 glasses. And our question we're answering is how much lemonade is in each glass. I'm going to start by drawing a bar model to represent 1 gallon. And I'm going to split that gallon into 5 pieces. And I'm going to shade in 4 of those units that I just created. And I'm going to label that 4/5. Gallons. Our problem tells us that she pours 1/4 of the lemonade into a pitcher and the remaining lemonade equally among 6 glasses. So since we created the 4 units to represent her lemonade, we're going to shade in one of those 4 units to show what she poured into the pitcher. I'm going to label that pitcher. And then everything that's left, those 3 units, is going to be what she poured into her glasses. Since she poured the lemonade into 6 glasses, we're going to split our 3 units into 6 equal pieces by dividing each of our units in half. I'm also going to divide our other pieces as well. So based on our model, for 1 whole gallon, that's equal to 10 units. We can figure out how much 1 unit is equal to by dividing by 10. Since 10 units divided by 10 is equal to 1 unit, 1 gallon divided by 10 would be equal to 1/10 gallon. So there is a 1/10 gallon of lemonade in each glass. Now we'll look at another strategy that we can use to solve the problem. Because she pours 1/4 of the lemonade into a pitcher, we can figure out the fraction of the remaining lemonade by using 1 to represent our total amount of lemonade, subtracting 1/4 to show the fraction of the lemonade that she poured into the pitcher, and that equals 3/4. Next, we want to figure out the amount of lemonade that was used to pour into the 6 glasses, and so this becomes a fraction of problem. So we're going to take 3/4 and multiply it by our total amount of lemonade, 4/5 gallons, because we're trying to find what 3/4 of 4/5 is equal to. Now we multiply, we can cancel out our 4's. And so we get an answer of 3/5. And this is the amount of lemonade for the 6 glasses. Now to figure out the amount of lemonade in 1 glass, we have to take our total amount for the 6 glasses, 3/5, and we're going to divide that by 6. Now remember, when we're dividing a fraction by a whole number, we have to find the reciprocal of the second number, which is flipping it around. And so we're going to take 3/5 and we're going to multiply that by 1/6, because 1/6 is the reciprocal of 6, and then we change our operation from division to multiplication. When we multiply across, we can simplify by dividing 3 and 6 by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. And then when we multiply across, we get 1/10. And so that's another way that we can get 1/10 gallon as our answer. Our last example says Philip buys 5 square yards of wrapping paper for a large gift box and some small gift boxes. He uses 2 square yards of the paper to wrap the large box and uses the rest to wrap the small boxes. He uses 1/2 square yard of paper for each small box. How many small boxes does Philip wrap? Now for this, I'm going to highlight the important information: 5 square yards, 2 square yards, 1/2 square yard, and our question is, how many small boxes does Philip wrap? And to start off, we're going to draw a bar model, and we're going to draw 5 squares to represent our 5 square yards of wrapping paper. Our problem says that he uses 2 square yards of paper to wrap the large box. And so I'm going to label 2 of those squares as what he uses for the large gift box. And then what's left is 3 yards, and that's what he's going to use for the small gift box. Now the question we're answering is how many small boxes does Philip wrap? And the way that we're going to figure out how many small gift boxes there are is by figuring out the number of 1/2 square yards and 3 square yards. And so what we're going to do is split each of our squares in half because our pieces are equal to 1/2 square yards. And then if we count up how many halves we created, that will tell us how many 1/2 square yards there are in 3 square yards. So if we go ahead and count, we have 1, 2, 3, 4, 5, 6. Therefore, Philip wraps 6 small gift boxes. If we look at another strategy that we could use, we know that he has 5 total square yards of wrapping paper, and he uses 2 square yards to wrap the large box. So we can do 5 minus 2 to figure out how many square yards are left for the small boxes, which is equal to 3 square yards. And so because he uses 1/2 square yards of paper for each small box, we're going to take our 3 square yards and divide that by 1/2, and that will tell us how many small boxes he wrapped. Now we do 3 divided by 1/2, we need to find the reciprocal of our second number and change our operation. So we're going to do 3 over 1, we're going to change our operation to multiplication, and then we're going to flip 1/2, which would be 2 over 1. Then we're going to multiply, and we get 6 over 1, which is equal to 6.